we're going to look at the nth term of a geometric progression. And then this is given as Tn is equal to ar raised to power n minus 1, where n is the number of terms, r is the common ratio, and then Tn is the nth term. And of course, a is the first term. Okay, so having said that, the major thing you need to know in the nth term of a geometric progression is this formula over here. And in the subsequent examples we're going to consider, we will see the applications of these formula, right? So let us consider the first question here. We're told that the first term of a GP is the short form for geometric progression. So the first term of a GP is equal to 7, while its common ratio is 3. Find the 11th term. Remember, the first thing I said you need to know is the formula for the nth term of a GP, which is Tn equals ar raised to the power of n minus 1 from what we have over here. So we were told that a is equal to 7 and r is equal to 3. Therefore, T11 will be equal to 7 times 3 raised to the power of 11 minus 1, because the number of terms is equal to 11. So T11 is equal to 7 times 3 raised to the power of 10 is equal to 59049. So if you punch your calculator, if you look for the value of 3 raised to the power of 10, this is what we're going to get. And then if you multiply it by 7, the answer is going to give you 413,343 as the final answer. So this is the 11th term of a sequence or a progression with the first term to be equal to 7 and the common ratio to be equal to 3. So this is the first application of the problems under the nth term of a GP. Let us consider another problem to illustrate this. We are told that the 8th term of a GP is 640, and if the first term is 5, find its common ratio and then find the 10th term. So if we pen down our parameters, we're told that T8 is equal to 640 and then A is equal to 5. So we can calculate the value of the common ratio from this. Since we know that Tn is equal to ar raised to the power n minus 1, therefore T8 is equal to ar raised to the power 8 minus 1, which is equal to ar raised to the power 7. Right? So if you do that, since we have T8 to be equal to 640, so this will be equal to 5 r raised to the power of 7. If I divide through by 5, I would have 640 divided by 5 is going to give us 128, which will in turn be equal to r raised to the power of 7. To make sure r stands alone, I'm going to take the 7th root of both sides. So taking the 7th root of both sides, this will cancel out, and then we'll be left with r to be equal to the value 2, because 2 raised to the power of 7 is going to give us 128. So since we have our first term to be equal to a is equal to 5, okay, and r is equal to 2, we can obtain the value for the 10th term. So remember that T10 is equal to ar raised to the power of 9. Okay, so therefore T10 will give us a is 5 times r is 2 raised to the power of 9. So T10 is equal to 5 times 512, which is equal to 2560 as our final answer. So when a is equal to 5 and r is equal to 2, then T10 is equal to 2560. So this is the end of the class on the nth term of a geometric progression. I've seen the illustrations or applications of the nth term of a geometric progression. So in the next class, we are going to consider the geometric progressions leading to linear equations. Remember that while talking about arithmetic progression, we saw that arithmetic progression problems can also lead us to equations, right? So geometric progression can as well lead us to equation, and that will be our focus for the next class. If you have questions for me based on what we've discussed so far, you can drop them on the platform, as our lead instructors will be available to attend to all your worries. Do not forget that we are a Waec.